So we'll be moving on to hear a little bit about Elevate Quantum and what we've been doing in our ecosystem building efforts. I'm pleased to introduce Zach Shami. He's the CEO of Elevate Quantum. He's been a great partner over the past year and a half or two as we've been thinking about how to really elevate the Mountain West. And with that, Zach.
Folks, hear me. Okay, that coming through? Yeah, there we go. Let's hear it again for the governor. It's an incredible honor. And now I'm going to try to, before we solve quantum mechanics, we're going to try to solve PowerPoint. We'll see where we get to first. Yeah, there we go. Gosh, thank you everybody for coming today. I'm Zach. I'm chief exec of Elevate Quantum. As I think we've heard, quantum will be, in some ways already is, the most important technology of the next century. It will be as critical as semiconductors were to the last 50 years. And we, this region, New Mexico, are in the lead. 8 Nobel Prizes, more organizations, more jobs than any other in the country. But with China outspending this country 5-1, we can't afford to rest on our laurels. So I have one message today, one core message, which is now is New Mexico's moment, right? Now. It's the opportunity we have in front of us because of the generations of work that people in the state have done, but we're on the cusp. And if we can pull together, literally the people in this room and activate the thousands, the tens of thousands, hopefully the millions that can get engaged in this industry, we can secure that opportunity for New Mexico and the country for generations to come. And we've taken a big step forward in that. The federal government has chosen Elevate Quantum, chosen this region as the nation's quantum tech hub. This is the first major place-based investment the US government has made. And they called it a Series A. Called it a Series A. That implies that this one program alone, the Series B, the Series C, the Series D, that's $1 billion, up to $1 billion in capital that can activate the potential in this region. And it's aimed to be catalytic. That's not counting NSF. That's not counting DARPA. That's not counting the endless opportunities we have in front of us. And they're doing it. Why? Like, what's going on? Why are politicians, world leaders taking photos in front of golden chandeliers if you're not familiar with the industry? It's a little bit perplexing. Fortunately, sometimes the golden chandeliers, they'll have some captions. They'll say quantum. So I think most people adjacently, as they look at it, they'll think it's a next generation computer made of gold, which is, that's kind of cool. It's a little Bonneville in it. Now, I think a lot of folks in this room, and just a sense check, who here is not a scientist? Raise your hands. There we go. Okay, cool. So for many of the scientists, they'll look at that, and most folks will see a next generation computer. We know it's actually a fridge, an amazing fridge. It's made by Maybell, and Corbin will talk your ear off about it. But it's a fridge. But the reason why Joe Biden, why countless world leaders, the biggest companies, are putting billions of dollars just into the fridge alone is because of the opportunity that we see here. The transistor, the backbone of our economy, which rode Moore's law to deliver the technology advancements that we've seen and utilize all around us, that Moore's law, the observation that as transistors shrink and the density doubles, you get a doubling of the compute power at each stage. That's running out of steam. Now, that's bad news in a general sense. But for certain problems out there, oftentimes quantum-y problems, they get exponentially harder as they get bigger. That's going to be a real problem because those sorts of problems, curing cancer, ending infectious disease, the current trajectory path that we're going on will never, ever be able to realize the capabilities that we see as critical to solving the biggest challenges of our time. And just one example there, a simple example. You look at something like penicillin, right? The backbone of our public health infrastructure. That is a small molecule. It's about 41 atoms. Now, if you wanted to use existing technology, classical technology, stuff that powers our cell phones and computers, you could actually model that theoretically. in order to actually realize that system, you'd have to turn you'd have to get 10 to the 86 transistors. And just to give a sense there, 10 to the 86 is a big number. That is literally akin to turning every single atom in the observable universe into a transistor, and still you might not be able to realize that. And quantum, the innovation that Richard Feynman came up with in 1981 was the realization that, well, what if you could use the building blocks of the universe to actually model these building blocks themselves? You could realize and rethink what it is to be a very computer. Then you could take something that would take more atoms than there are in the observable universe to actually solve, and you could reduce that to 286 bits, quantum bits, and realize that. And because of the exponential nature of this technology, once you've gone from 286 to 287, it's not just a marginal improvement. It's penicillin interacting with its neighbor. And once you've gone from 287 to 1,000,000 qubits, it's not just a bit better. It's the realization of you as a patient walking into your doctor's office with what today would be a life-ending disease, and walking out of that same office minutes later with tailored medication that stops death at death's door. And that's why those problems that look like penicillin, which is climate change, which is curing cancer, which is some of the biggest challenges of our time, they open up $3.5 trillion in our economy. That's per year, and it's just in America. And to give a sense, I mean, this is an unimaginably big number. That's about the scale of the healthcare sector, the financial services sector, and that's on our doorstep. And actually, one last, just, the thing that occurs to me, Corbin and I talk about this. This is a little bit like, in the early transistor revolution, basing the entire opportunity of semiconductors based off the one killer application they knew about at the time, which was a hearing aid. Right? We are on the cusp. And just with that realization, we can see something, the scale of the healthcare sector in our economy. And New Mexico can be the lead of that. And it can be the lead because this opportunity didn't emerge overnight. Right? We heard it from the governor, we've heard it from many today, that the national labs, the universities, they form the foundation of this technology, and they've been going back 8 decades in order to do that work. And because of the relentless focus on national security and the translation of those technologies, so it's not science for its own sake, which is amazing, but it's not. It's actually to translate that to the most critical customers in the world in the national security sector. We get these innovations escaping the lab and realizing in market. You look at GPS, which powers you look at GPS, which powers our national economy. You look at atomic clocks, which power the internet. It's something that has affected all of us. And that's why you put together the world's biggest customer, the largest demand, with some of the world's best science, and you get the greatest concentration of industry talent anywhere in the world, certainly so in the US, right here in our region. It's more jobs, it's more organization than any other. Every single one of these companies here, though, there's an inconvenient truth. Every single one of these companies here, they owe their existence to the state of New Mexico. Owe their existence. They come here all the time. I could show a bigger list. Big tech companies, they're here every single day, but they quickly get on a plane and they leave. And so the thing that we have to face in front of us is, how do we take the biggest organizations that are already coming here? They don't go to other places. They're coming here, and actually have them stay and scale in the state. Now, Colorado, most of these companies are headquartered there. The reason why they're headquartered there are a lot more industry jobs there. It's not rocket science, it's tech transfer, right? From the beginning, near the beginning of the relationship with NIST, an amazing national lab, it had a relationship with CU Boulder, where the innovation at the lab could legally escape the lab and start companies with that. It's not rocket science. And the thing that occurs to me, the reason why I'm so excited, apart from the amazing innovative work that QNMI can do, is today is New Mexico's moment to realize the exact same opportunity. The QNMI, the connectivity between the University of New Mexico and the national lab ecosystem around it, resubstantiates the model that we've seen time and again does not just the world's best science, does not just act as an anchor for companies to stop by, but actually is the foundation for generations of economic opportunity and thriving industrial sectors right across the board. And if we do that, if we pull together as an organization, as government, as science, as industry, we can realize the scale of economic opportunities that are unimaginable in short order. We're talking about with this initiative, in less than 5 years, creating over 10,000 jobs. 10,000 jobs from a small program, right? And ultimately, these are not just jobs. These are the classic good jobs that make for the backbone of healthy, thriving, engaged economies. 50% of these jobs across the nation don't require an advanced degree. I think when people think of a quantum job, they go to somebody with a PhD in math and chalk on their hands. No. In our region and the jobs that we can create here, they're building stuff like what's the center picture there, a fridge. And to do that, it looks more like building an aircraft engine than it does to get a PhD in a math lab. And so in these economies, it's not 50% that don't require an advanced degree. It's up to 80% that do not require an advanced degree and complement, like an aircraft engine, the incredible skills at the labs and the PhDs and the advanced degrees that people realize, and still pay $125,000 a year. And so as we put these puzzle pieces together, you have the world's best science, you have industry and customers that come from the national security sector, and you have the building blocks, the facilities, the relationships with the QNMI. I see the past, the present, and ultimately the future of quantum right here in our backyard. And the only reason that we've arrived at this stage is because of you. It's because of 3 decades, literally 3 decades of hard work from Ivan in order to actually realize this institute. I don't think it relentlessly focused on this, literally for decades. And that's what it takes. It's Jake and the entire Sandia team who both bring workforce leadership, quantum leadership, and really imbibe the values of how are we going to do this, having everybody, a whole region, a whole set of technologies at the table from the beginning. It's Mike Rabin with, both words get emails from Mike Rabin. They're like little motivational posters in email form. They're amazing. They power our business. And of course, the capability that Lionel brings that he is closely there with. It's Corbin who, in some ways akin to Ivan's fight for decades to realize this here, relentlessly says, gosh darn it, because he doesn't actually swear. It's a Corbin thing. He says, gosh darn it, this is going to stay in the Mountain West. And then we think, of course, of Alex Greenberg, Nora, who works with the state, and ultimately the governor, in realizing what is critical. We've seen at every stage, a close partnership between and activating the entire state infrastructure in order to make this happen. But the thing that hit me, Corbin and I were at a presentation with about 50 generals, and we're walking out. We realized that to take the sorts of commitments that we've activated here, hundreds of millions of dollars, that's a life-changing amount of money. But we realized at the same time that same amount, that doesn't buy you one training round in the latest AI models, right? So with something that you could secure generational leadership in, right? If you have the right foresight, if you invest that in the right area, you can actually secure, and that can't come from just any industry. And if you look back and history this is a little bit double-edged. That also means that other ecosystems, other national players, the CCP looks at that and says, I don't need trillions of dollars. I need to make the smart investments in the hundreds of millions and billions in order to seed that. And New Mexico is no stranger to missing out on that opportunity. And so we both have to have the support, we have to have the strategy, and we have to have the folks in this room activating everybody in this ecosystem and well beyond it in order to ensure that we can retain the technology that will define the next century right in our borders. And we're not alone. Elevate Quantum and all of our consortium members have joined on board in order to realize the simple to say, harder to do vision of securing the Mountain West, right? New Mexico, Colorado, and Wyoming as the global epicenter. And that's not just in its own sake. It's not for a trophy. It's because nothing could be more important as a technology and economic package to secure our nation's economic and national security future. Because of the folks in this room, because of the connectivity, because of that hard work, I have every confidence we can do that. And that's because we have done it before, right? Quantum, we've realized some of that. There's still more work to do. But the model for this, we know. It's how do we reinvent, how do we realize, resubstantiate the miracle that happened with the space race? Get the fundamental science, that vision, but then how do we maintain that edge, right? Particularly so for a place like New Mexico, which we can miss out on the opportunity to realize that in our borders. And in that same meeting with the 50 generals, what occurred to us is we do some things really well. We do the fundamental science. We do those moonshots. But you also have to be deliberate about the sorts of activities that enable you to maintain your edge. And if we look at telecoms or we look at semiconductors, what we missed out on is the US fell behind, not because it didn't have the best ideas, not even necessarily because it didn't spend enough money on it, but because our competitor countries could iterate literally 10 times faster. They could go from an idea to a thing to a widget to sell that faster than we could ever imagine. And so you take an example like a PIC, which is a quantum example. Some of the biggest companies in our country, if they want to realize this PIC, photonic integrated circuit, core component that they're going to need to scale, they go from a great idea and realize that maybe, if they're lucky, 9 to 12 months later. In China, that would take weeks. In Northern Europe, that would take weeks. And so as we sit here in this room, we try to say we have the biggest opportunity of our lifetimes. What are we going to do that in some ways is not quantum, it's core engineering, in order to go from the world's best ideas to life-changing technologies and job opportunities, again, for absolutely generations to come. And we're fortunate that the person that's leading that from New Mexico is here to go into that today. He's been our gracious MC, Jake Douglas, coming from Sandia. And he's going to give folks a window into the strategy that we have that relies on all of you in order to make it happen. So again, I want to thank everybody here. I want to thank the governor and Alex and the team, and certainly so Jake, if you want to come up and hug him.
Awesome. Thank you so much, Zach. Yeah, so Zach kind of laid the background there, right? Of what are we trying to do? What are our motivations? And like he said, I want to talk a little bit about our strategy and our approach to how we're doing this. And I do want to double down on the regional piece of things, right? We've been able to have great success by partnering closely with Colorado, but we also know that New Mexico hasn't quite got the same resource from what we've done thus far. And we're really interested in how we can right-size that now. And so if we're talking about Elevate Quantum, what is it, right? We've talked about it a ton today, but it is part of the CHIPS Act that is administered by the Department of Commerce and the EDA. And it is a program that has been authorized for $10 billion. The idea was they would establish these regional tech hubs around specific technology areas in microelectronics, and make these critical investments in place-based groups that can really drive the field forward. And so in 2023, EDA did the first down select from a little over 400 groups down to 31 tech hubs across the US, where they said, hey, we think you can come up with a compelling idea, prove it. And there was one other group outside of Elevate Quantum that was selected in Quantum, and it was out of Chicago. They have a very strong group there. And so we saw it as our job to compete with them and try to prove that the Mountain West is the place to be for Quantum. And we were notified in July that we were selected as the only quantum tech hub for the US, with this really heavy emphasis and focus on economic development and job creation. And we're very excited to have won that award. But we also want to talk about moving forward. How can we continue building on this success, capitalizing on the foresight and the decades of investment that we've seen across the region? And so we'll talk a little bit today about what we're hoping we can achieve through the NSF Regional Innovation Engine. How can we have a New Mexico-led, a New Mexico-based, a New Mexico-driven proposal that's able to bring in more partners, that's able to address the needs of our communities and help drive impact for the state? There's also things going on, across the federal government. Quantum is critical. We've heard from speakers all morning about how important this technology could be if realized. And so we're seeing things like DARPA coming out and saying, hey, we don't know if quantum's going to work, but if you prove it, we'll make big investments and we'll move it forward. And so folks like Setso Matodi and Mike Rabin and others are helping coordinate that from a New Mexico side with our Elevate Quantum partners. And of course, we have our flagship programs that are already here. The Quantum Systems Accelerator is one of the 5 DOE flagships that Sandia helps run. The Quantum Science Center, Los Alamos National Labs plays a key role. The NSF Quantum Leap Challenge Institute, led out of Colorado, with UNM as a key partner. And so we're no strangers to these large-scale flagship programs, and we're excited to lead one out of New Mexico. So let me say just a little bit more about Elevate Quantum and how it's structured, just to give you a little bit more information. So at the very center of Elevate is the Unite pillar, right? So that's Zach leading as the CEO, and that's the staff that is bringing everything together as the central entity to help coordinate. But the real efforts and the ways that New Mexico is going to be engaged is through these pillars. So we asked the EDA to support workforce development, open access, quantum fab lab, accelerator programs, and ways to help scale up, industry. And they funded our open access quantum fab labs and our workforce efforts. They decided not to fund the accelerate piece. That doesn't mean that that's not a critical part of what Elevate Quantum is looking to do. That just means we have other avenues to go down to realize that vision. On the create side, the idea is there are current gaps or opportunities within the supply chain, the hardware side of things, where we'd like to speed up that iteration loop, where we'd like to do faster prototyping. We'd like to go through and work with the community to understand what small investments can have outsized impact for the field right now. And through the Elevate Quantum Award, we're going to be able to stand up a facility both in Colorado, but also in New Mexico. So UNM is going to be partnering with Sandia and Lannel to set up a heterogeneous integration lab that's going to focus on quantum. So we're working very closely with Ivan and Dave Hansen in the VPR's office to try to understand how can we set that up in the most impactful way. And over the next 6 months to a year, we're going to flesh out that vision and understand how that can help enable our local ecosystem. We're also very, very interested in how we can build the education needed in the programs across the full spectrum. How can we start engaging at the call out for the middle school camps, right? We built out high school camps. We have a program underway with CNM to train quantum technicians. We have our amazing programs at UNM and New Mexico Tech and NMSU to train our undergrads and our grad students. And we want them all to be in the room. And through the Elevate Quantum opportunity, it's going to focus on the current gap and the opportunities that the industry has told us we have, which is quantum technicians, and trying to drive towards jobs right now. And so as was stated, over $100 million unlocked for this, about 10 million from New Mexico. Still some questions to be answered there. Happy to go into that later though. And we're really excited for this initial tranche of funding, but we see this as just the start. And so to try to further build on the innovation ecosystem that we already see here in New Mexico, we're pursuing a National Science Foundation Regional Innovation Engine, which is a sister program to what we see from EDA and the tech hubs, that's focused on bringing in national lab partners, academic partners, industry partners to drive economic impact, but with a little bit more of a flavor on how can we build the research collaborations and the whole ecosystem that can support the advancement of the field. And so with partners from across the board, we're going to really focus on how we can drive that innovation acceleration here in the state. We think we can come out with really transformational technologies over a 10-year period. We think we can bring industry here and help scale them with partners like NMEDD and our state partners. And importantly, we want to provide high value, high impact jobs for those from New Mexico. And it's going to be led out of the state with partners across, again, New Mexico State, New Mexico Tech, UNM, CNM, Sandia, Lanel. And this is something that we don't see terribly often, the whole state coming together to try to move a field forward. And we're excited to be able to do that in a really meaningful way. And so what are we doing, right? We're coupling really rapid capacity building with our very healthy, robust research ecosystem to try to drive innovation in quantum technologies over the next 10 years. So we're going to leverage what we've been able to do with the Quantum New Mexico Project and Institute with Elevate Quantum to focus efforts on 3 grand challenge problems. We're going to look at quantum enhanced position, navigation, and timing. We're going to look at securing networks, and we're going to look at quantum computation for things like material science and energy. And these things all matter to the state. They matter to our national labs, to our universities. And with focused investment, we think we can drive accelerated quantum tech commercialization and create those jobs and really establish ourselves as leaders in the field. And we're excited to do this with kind of partners across the board. And we're going to do that in a few different ways. And so with everyone here today listening, to what we have to say, we wanted to share a little bit about how you could get engaged, right? So first and foremost, coming to events like this, right? Learning, networking, understanding who's doing what is really critical. And the Elevate Quantum team is starting to hold sessions to educate folks about what we're doing, both generally like this, but diving in to more detail on specific funded projects the EDA is looking to stand up. Advocacy for quantum in the state. There's not a lot of opportunities right now to learn about what quantum is, and so we're trying to change that. If you're, one of the scientists in here, which I believe is about half the room, how can we get the word out and share what's happening in the state about the groundbreaking research that we're doing? Because as much as the work that we do here, Chicago is really good at marketing, right? I'll just throw that out there, right? So how can we tell our story better, right? How can we let people know that we are making those foundational breakthroughs? We would love to get engaged on the engine, right? We've touched on it in a few different ways. Our ecosystem has world-leading national labs and academia, but we are missing industry. We might have 2 quantum companies in the state as it stands right now, and we need that to be 10, right? If we want the rest of the state to benefit from this, to help drive innovation, we need co-location. Right? If they can just come down the street and work with us in our labs, we'll be able to more rapidly innovate. And then, of course, we want to get connected on things that are meaningful to your community. So workforce is one that we're particularly passionate about. So we have a collaborative that we've stood up that has strong representation from New Mexico, Colorado, and national level folks. And we'd love to understand how to work with your students, your communities. As we're standing up the labs, the fab labs that the EDA has set up, we'd love to get your feedback. We want to hear from industry that, yes, this is what we need and this is providing value. And we want to know what students we can bring through to train them on those systems, things of that nature. And then, of course, we'd love to just talk to you about your ideas. What's been sparked today that might be of interest that aligns with what you're already looking to do. We have incredibly strong partnerships already, but it's not enough. In our EQ kind of snapshot of partners, we highlight 6 or 8 New Mexico companies and organizations, and we'd love to see that grow to dozens. And so we hope that through today, we can help make that happen. Through the engine, we can help make that happen. And we appreciate everyone coming here today to learn about why you should get engaged with us. So thank you. Awesome. So next up, we wanted to hear from an industry partner. And we've been working with Quantinuum since they launched, both on developing ecosystems. They're a key partner in Elevate Quantum. They're great R&D partners. And so we're excited to hear from Jenny Strabley today on why New Mexico checks all the boxes.
Okay, thanks. Thanks, Jake. Thanks, everyone, for listening today. And I want to thank Ivan for inviting us to come. I've been making several trips down to New Mexico over the course of the last year. And really beyond that, New Mexico is just one of those things that just keeps coming into my life. And so it's fun to come back every time to New Mexico. But what we've been talking with Mike and Jake and Ivan about is how do we get more industries to come, quantum industries, to come to New Mexico? And one of my key phrases has been, it checks all the boxes. So before we get into what those boxes are, I'll just say a little bit about Quantinuum. So we are a company that was founded in 2021, but it was a merger of two companies prior to that that had each been around for 8 to 10 years. So it's not a startup by any means. It's 500 employees focused on quantum computing, quantum technologies. It's what we call a full stack quantum computing company. So that means we cover from the metal layer all the way up to the applications. And we are a global company. We have our headquarters outside of Boulder, Colorado. We also have facility in Minnesota and in Washington, D.C. And then globally, we have 3 offices in the UK, 1 in Germany, and our fastest growing site right now is in Japan. And 500 employees, huge amount of that, 375 plus are scientists and engineers. I fully say that a lot of PhDs, but we hire everywhere from bachelor's degrees, master's degrees. We hire experts in legal, we hire experts in facilities. So there's a lot of jobs other than PhD scientists. And we really pride ourselves on our innovations, 80 patents, 155 publications, and a lot of innovations come out of this company. What do we offer? So we offer hardware that people can use and develop, quantum hardware that people can use and develop their use cases. As I mentioned, we're a full stack company. We offer this out to our user community. So we've got a very vibrant user community. Over 100 papers have been published using our hardware. We have over 500 users. We have open source tools with over 1.5 million downloads. But we also partner with major blue chip companies. So we have customers in the financial institutions, HSBC and JP Morgan. We partner with top industrials. We partner with US Department of Energy labs, and then Japanese, the equivalent in Japan, which is called Reiken. And we also partner with Microsoft and as a cloud service provider and also as a research partner. So what do we work on? So this is our full stack, but more importantly, we work with companies on some of the most practical yet critical applications. So if you look across that list, carbon capture, semiconductor defects, fuel cells, drug protein interactions, and the synthesis of new types of refrigerants. So some of these might seem a little bit not what you expect to come out of a quantum computer, but they're problems today that are intractable for a classical computer. And in the case of a lot of these chemistry and materials problems, the result is they have to rely on bench testing, laboratory testing, and that slows the time to market. The more you can push that into a compute framework, you can get a faster time to market. And some of these technologies, all these technologies are critical not only from an economic perspective, but also are from an environmental and sustainability perspective. We also do a lot of fundamental research. These are our publications that just from the last 6 months. Some of these are preprints that are on the archive. Some of them are published, but you can see as you read those, it's everything from very, very fundamental functions for a quantum computer, such as error correction, chemistry use cases, AI use cases, and that's just, again, from the last 6 months. So someone like myself, what I spend a lot of time looking for is how do we grow an ecosystem? And one of the most effective ways to grow an ecosystem is to be there. It's really hard to grow an ecosystem. Even for me, I'm only a 50-minute plane ride away, but it'd be much better, as Jake said, if you were just down the street and you can have a very close collaboration. So I have 3 boxes that I look at for why would you want to go to a specific place. I want to be close to users, so the people who use our systems. I want to be close. I want to hear what they have to say. I want to hear what they need so that we can factor that into our development plans. I want to be close to suppliers and development partners. I think most people know that the quantum supply chain is a bit brittle, has a lot of single point failures, so we need to grow that. But we also need to develop some of these technologies. They're not just on the commercial market. And we want to be close to the workforce. We want to be involved in their education. We want to know who's coming out. We want to go get them into our company as quickly as possible. So when I think about New Mexico, some of the best users of our quantum computer are here. Here are just some preprints that have come out from the users in New Mexico. So that's a big check of that box. Close to suppliers and development partners. So I took this photo from Sandia, but it's already been mentioned that Sandia has one of the premier fabrication facilities. They make ion traps, they make photonics, they have a test bed for ion trapping technologies. And that's just one example of the supply chain that could be developed here in New Mexico and also the development partners. So I think that gets a big check. And then the last is close to workforce. And as Ivan showed that picture, I could see people from Quantinuum. Some of our best technical leaders have come out of the New Mexico education system. And so that gets a big check. So New Mexico checks all the boxes for a company like Quantinuum to come and establish a presence here. And to help with this, our CEO has provided a quote. As the established leader in quantum computing, Quantinuum finds a perfect match in New Mexico. The state offers a vibrant technology ecosystem and a talented workforce that naturally fits our needs. It goes on, but it's, this I think is a reinforcement to say how important New Mexico can be for companies like Quantinuum. And so I'll just stop. This will be my last slide, but I wanted to remind those of you in the audience, and maybe you don't even know this, when Elevate Quantum was being formed, companies like Quantinuum gave a letter of commitment to Elevate Quantum, and we gave a second letter of commitment to the state of New Mexico, saying we're going to give some things to the state of New Mexico. We're also going to give those to Elevate Quantum, so you have a possibility to double dip, to really kickstart this Quantinuum New Mexico relationship. So those are discounted access to our quantum computers. We've already started some of those projects in Colorado. Love to start those now in New Mexico. We have paid opportunities for internships. Those are already posted on our website, and if there's one you think that's missing, please come talk to me. And then we have funding for collaborative research projects. I'd really like to get those kicked off and start doing collaborative research with those of you in the room from New Mexico. So hopefully this will be yet one more catalyst to continue to drive this close relationship between Quantinuum and New Mexico. So thanks again for having us, and look forward to spending the rest of the day with you.